Okay, hello everyone. I'm Lei Shi. I'm now a graduate student at the Institute of Software, Chinese Academy of Sciences. And this work was done when I was the research intern at Microsoft Research Asia. And in this work, I will present an unsupervised template mining algorithm to mine some templates to understand a large-scale set of semantic category names. So firstly, I will give a brief introduction about semantic category names. A semantic category name is a plain string which can describe a set of items sharing common semantic properties. For example, I gave two examples here. The first example is about Carnival Christmas. These two items share the category name National Holiday of Brazil. And the second example is Loctuarial weight loss. They share the semantic category of simple term of insulin deficiency. So there are many category names in the real world. Some of them are manually added. For example, in some existing knowledge bases like Wikipedia, we know that there are many entities in Wikipedia. Each entity have a page. In the bottom of the page, there are many category names to describe the entity. And another way to get the category names is to automatically extraction. There are some hypernymy or is-er relation extraction techniques in recent years. So please note that I will use the term category name and category interchangeably in this slide. So as there are so many category names and they are in plain text, how can we understand these category names? Or especially, how can a computer program to infer the semantics from the category names? Actually, there are some internal structures in the category names. For example, here is a set of category names, CEO of General Motors, CEO of Yahoo, or CEO of Google. We can find that there is an internal structure as CEO of company. We can use CEO of company to represent these category names, or we can summarize it as CEO of company. In this work, we call CEO of company as a template. So a template can be a semantic representation of the category names, and it can represent a set of category names which have the similar structure. So there are several potential applications of templates. One is that these templates can be used as additional features in some tasks like web search and question answering. And another application is that we can use the templates to clean a noisy category names connection, and we also have experiments in this application. The third application is that we can use the templates made it possible for a computer program to infer the semantic meaning of category names. For example, here is the category name. Here is the category name. Simple term of insulin deficiency. We can link it to two templates in the right. So by linking it to the templates in the right, we can interpret the category name as a kind of simple term of a medical condition, and the name of the medical condition is insulin deficiency. And insulin deficiency is a kind of hormone deficiency, and the name of the hormone is in Shuming. So by this way, it made it possible for a computer program to infer the semantic meaning in the category name. So here comes the problem. How can we get these templates automatically from a large collection of category names? Actually, we can define some templates by human beings, but there are so many category names. So we should find automatical algorithm to get these templates. And this is the focus of this work. Here is the outline of my talk. Firstly, I will give the definition of the problem, and then is our approach. The following is the experiments and the related work. And last, I will conclude this work. So here is the problem definition. The input of this work is the large collection of category names. And in our experiments, we perform hypernymy extraction on 3 binary English pages, and we get 40 linear terms and 740 linear hypernyms, and 321 linear edges. These edges is the mapping from term to hypernymy. For example, if a term is Beijing, and it may have a hypernym as capital city of China. And then we connect all the multi-word hypernyms as our category name connection. This is our input. And our output is templates. A template is a multi-word string with one head word and several arguments. For example, here is a template. The holiday is called the head word, and the country is called the argument. For each template, we will assign it a score, and this score will indicate how likely the template is valid. Here are some example semantic categories and its corresponding category templates. We can see that there are category names like school in Denver and school in Houston, and we can extract the related templates like score in place and score in city. So a straightforward way to get the templates is 2 steps. The first step is divide, and the second step is replace. So in the divide step, we will divide a category name into several parts by referring to an entity dictionary. So for example, here is a category name, CEO of Delphiners. We can divide it into CEO plus of and plus Delphiners. And then we replace some key segments by its hypernym. In this example, Delphiners is a company, and it's also a constellation. So we will replace it with the 2 hypernyms, and we can get a CEO of company, which is the valid template. But CEO of constellation is not valid because it's semantically incorrect. So the main challenge here is the ambiguity. Many segments have multi-meanings, but as we know that there is a context, so we should find the exact hypernym for the context. In this example, CEO of constellation is the wrong template. So here comes the approach. I will introduce an intuitive approach first. So the intuitive approach consists of two stages. The first stage is category labeling. It consists of 3 sub-steps. The first step is to segment a category into several parts, and each segment is one word or a phrase in an entity dictionary. Here the entity dictionary we use is from free-based data. For example, we will segment holiday of South Africa as holiday plus of and plus South Africa. And then we will map each segment to its hypernym. Here we use a term to hypernym mapping from a dump of previous data. Please note that there is no weight information in the term to hypernym mapping in previous data. So we just know, for example, we just know China is a country, and China is also a book in previous data. And then the third step is called candidate template tuple generation. For example, here we have holiday of country, and by replace Brazil with country, and we also can get holiday of book by replace Brazil with book. And here is some definitions. Here we call country as the argument, and Brazil as the argument value. W1 is the tuple score, which indicates the quality of this tuple. So then the second stage is template scoring. Firstly, we merge all the candidate template tuples for each template. For example, we group all the holiday of country tuples, and we get these tuples. And then we can represent this tuple as this. And then we use our scoring function to get the score of the template by all these tuples corresponding to it. This is the TF IDF style function. Here, WI is the tuple score, and H is argument type. For example, country is argument type of holiday of country. So here we use IDF because for example, H, if H is a common topic in previous data, it means that it will have a little IDF score. But if a topic is very common, when it appears in a template, the probability of the template is valid is very little. So this means that we prefer to select the topic which is specific rather than the common topics. And then is the estimation of the tuple score WI. As I have mentioned in the previous slides, there is no weight information in the term to hypernym mapping of previous data. So we can simply set all the tuple score as constant value. Here we set it as 1. It's also needed to note that here the scoring function is the linear combination function. So in this figure shows the overall workflow of the intuitive approach. Firstly, we get some category names, and by referring to a term to hypernym mapping in Freebase, we can get the candidate template tuples and also the tuple scores. And then we use a linear combination function to get the score of each category templates. And then we can rank the templates by the score and to filter the bad templates. So in the following slides, I will introduce 3 techniques we use to enhance the template scoring. Firstly, we will enhance the tuple scoring stage. In the intuitive approach, the WI is just simply set as the constant value. This is not very reasonable. So we use we leverage statistical information from large corpus to estimate the tuple score WI, and then we will analyze the linear combination function and find there are some limitations of this function. and we will use nonlinear function. At last, we will use term similarities and term clusters to improve the performance. So here is how to enhance the tuple scoring. Firstly is intuition. For example, here is the holiday of country by replace South Africa as country, and here is holiday of book by replace South Africa as book. So in the intuitive method, W1 is equal to W2 and equal to 1. But this is unreasonable because we all know that South Africa is more likely to be a country than a book in the text. So we will have W1 is larger than W2. So how to do this? The idea is very simple. We performing statistics in a large scale corpus and get the property f of a term hypernew pair by referring to a corpus. And then we use these two functions to estimate Wi. The first function is just to get a log skew of f, and the second one is like a conditional probability. It means that if we know the argument value, then we can know given the argument value, the conditional probability of H. So here is how we use a large-scale corpus to estimate Wi. And then is the triple compilation function. In the intuitive approach, we use a linear function, and we will analyze this function. We have some definitions here. T indicates that template T is a valid template, and this means that T is invalid template. And EI means the observation of tuple UI. So we calculated the posterior odds of U and T given U1 and U2. Here we have assumption that is U1 and E2 are conditional independent given T. So we can get these equations, and then we can get this. This is a log gain of T given E1 and E2. It equals to given E1 the gain and given E2 the gain. So it's very easy to get this equation. And then we will analyze the connection of this equation to the linear combination function. So let's assume this equation, and we can get that the linear combination function is just in this form. So, but this form is get by assume that E1 and E2 and En is conditional independent, but this may not hold true in reality. So here we use some nonlinear functions, and these functions are also used in Zhang's work. In their work, they are focused on the task of hypernymy relation extraction. Here we choose the P long. And in the experiment, we empirically set the P as 2. And here is an example of the advantage of the nonlinear functions. For example, for this template city of country, we assume that there are 200 tuples corresponding to it, and the average score for each tuple is 1. And for the template city of book, we have 1,000 tuples corresponding to it, and the average score for each tuple is 0.2. So by use the linear functions, we can find that these two templates get the same score. This is unreasonable because city in country is much better than city of book. So by using the nonlinear functions, we can find that the city of country get a higher score than city of book. So the nonlinear functions is more reasonable. And at last is the refinement with term clusters. Here is intuition. For example, we have these category names, city in Brazil, city in South Africa, and so on. And we also observe that Brazil, South Africa is very similar. So this means that these terms are very similar and they appear in the same context, the city in context. So it means that it's more likely city in country is a good template. So inspired by this observation, we propose to use term clusters to help us to improve the performance. Firstly, we build some term clusters. Firstly, we calculate the term peer similarity. For example, a dog and a cat are a peer term because they are all animals. And we use the techniques proposed in this work to get our peer similarity graph. And then is the clustering step. For each term, we choose top 3 of its labels, and then run a hierarchical clustering algorithms on these 3 labels, and then we will get several clusters. And for each term, we will get these clusters, and at the last step, we will merge highly duplicated clusters, and then we can get several clusters of all the terms. In the last step, we will assign each cluster the top hypernyms. For example, as China, Brazil, Africa are in the cluster, and we also have the freebase term to hypernym mapping. So we can assign the top hypernyms to this cluster and name this cluster as a country cluster. And here is the template scoring refinement. Here is some definitions. A template T with argument type H and its supporting tuples is as U1, U2, and UN, and V1, V2, and Vn is the corresponding argument values. We have an observation here. By compute the interaction of V and every term clusters, we can find that for a good template, at least one cluster which has the hypernym edge, and it will contains many elements in V. But for a bad template, for example, for template city of book, only the cluster only contains a few elements, very few elements in V. So we use this equation to calculate the supporting score from one cluster to the template. Here, KCV means that the number of interaction elements of the cluster C and the V set, which is defined here, and WCH means that the hypernym H is the weight of the hypernym H in the cluster C. It means that if KCV is large, it means that we should add a large supporting score to the template, which is consistent with this observation. So for each template, we will get several supporting scores from the clusters, And then we will choose this score, which is the largest score, and to multiply it with the original template score to get the final template score. So the following is experiments. The data source we use is the large corpus containing 3 binary English web pages, and we extract 74 binary category names as our input. And the data set we use is that we use 2 data sets. One is that the subsets. We choose 20 diverse header words from our header word set, and for each header word, we connect all the categories sharing the header word. For example, simple term of insulin deficiency and depression, simple term are in the same set, and this is our subset. And the fourth set is all the 74 binary category names. And for the labeling is that we will get okay, 1 minute. Okay, we will get a list of templates, and we will ask people to label it as good, fair, and bad, and the metric is precision. So here is comparing methods. The base method is the interview method, and the AR, W, and LP method is the method which uses a linear combination function, and NR, W, and NRP is a method with nonlinear functions. And these methods are use the clusters to refine the final score. So here are some results. We can find that by comparing with the best method, the LW method have improvement. This indicates that the weight information is very important. And by comparing LW and NLW, we are finding that the nonlinear functions is very important. And with the refinement of clusters, we will have also have improvement. And these results, by analyzing these results, we can get the same conclusion. So here is the NLP plus C method on the fourth set. By this experiment, we can choose the number of templates according to the requirement of the applications. And the last one is applications. We can see that by using our templates to clean the category name collection, the precision can increase from can have a big improvement. So here is some retail work, and here is a summary. Okay, thanks for your attention. And any questions?
Well, thank you. We are running out of time, so anyone has a quick comment or question? Okay, so I wonder whether you want to try any other applications rather than cleaning up the category. Do you have any plan to apply these results to question answering or any other applications?
Yeah. I have that plan, and also there are some other future work as to applying our approach to general short text template mining and something like that.
Okay, great. Thank you.